All right, so this is the second part for straight line motion. So here, if I use the graph to the right to answer the following questions. When is the particle moving to the right? When is the particle moving to the right? All right, so it's asking for an interval. So the particle moves to the right when the velocity is what? Greater than 0, no? When the velocity is greater than 0. This is the velocity graph. So when is the velocity greater than 0? See the velocity, this 0, greater than 0 would be what? From 0 to what? To 1. It had high velocity, then it went down to 0 velocity, and then negative velocity here, then it went positive velocity. So let's say this is 4.8. So it's going to go from 0 to 1. So what are we going to say? When the velocity is greater than 0? And it's from 0 to 1 and from 4.8 to 7. When is the particle moving to the left? When would it be when the velocity is what? Less than 0, no? So when the velocity is less than 0, it would be from 1 to 4.8. When is the particle's acceleration positive? Let's do this one first. When is the particle's acceleration positive? Yeah, let's not even pay attention to this right now. Not this. When is it positive? When is the particle's acceleration positive? When is the particle's acceleration positive? One way to look at it is a description of the velocity. So acceleration is a description of velocity. Of velocity. Let me see. What do I mean by acceleration is description of velocity? This is velocity. So we're looking at it in another way how we looked at increasing, decreasing. And that would be position. And velocity describes position. Now acceleration describes velocity. So it's the rate of change of velocity. Rate of change of velocity. So when is the slope of velocity? When is the slope of velocity positive? When is the particle's acceleration positive? Is when is the slope of velocity positive? Because this is velocity. So when is the velocity positive? From 2 to 6 would be when velocity is positive. That's it. That's all. So positive when v prime is greater than 0, and it's going to be from 2 to 6. So then when would it be negative? 0 to 2 and 6 to 7? And when would the acceleration be 0? When would it be 0? When velocity doesn't change. When is that? Does it have it? When it doesn't change? Would it be here? Would it be here? Let's see. So it doesn't have any where it doesn't change. So let's move on from there. That one. All right, let's go D. When does the particle have the greatest speed? When does the particle have the greatest speed? What is speed? What is the absolute value of velocity? We said that, no? So when does the particle have the greatest speed? Would it be right here, this one? At 0 and at what? At 0 and 2, no? Yeah, 0 and 2. At time equal to 0, time equal to 2. This one's still a bit lingering question on the 0 here. All right, let's move on though. Let's move on to D. E. When is the particle speeding up? When is the particle speeding up? Didn't we already talk about that on Monday? When does a particle speed up? Velocity and acceleration are the same direction, have the same direction. Or direction means if they're positive or negative. So isn't it, let's take a look at intervals here. So this is what? This is a velocity that is what? Positive, no? Velocity is positive here, no? It's positive. And the slope of it, which is acceleration, is what? So that can be, I just did that part because, and then we'll do this other one here. This one is that velocity is negative and acceleration is what? Negative. They'll match up, no? Yes? The slope of it is acceleration. So that would be what? From 1 to 2. And then what else? This wouldn't be it, no? Because velocity is negative here. And acceleration is positive, no? That would match up. How about here? This one is what? Velocity is positive. And acceleration is what? Positive. So those are it, no? So it's from 1 to 2. And 4.8 to 6. And F, when is the particle slowing down? Slowing down is when they don't match up. We said here already, this was positive acceleration, positive velocity, and negative acceleration. That's going to be it. And then this one also is going to be it. This one is velocity is negative and acceleration is positive. So 0 to 1, and then 2 to 4.8. And also over there, this one, that's velocity positive, acceleration negative. All right, let's go to number 6. A particle moves along a straight line for t greater than or equal to 0. The position of the particle is given by this third degree function, where t is measured in seconds and s in meters. Find the velocity of the particle at any time t. Just take the derivative, and you're now evaluating, so you just want to just take the derivative of it, s prime of t. So what is that? Minus 12t plus 9. That's it. At any time t, that would be the formula for it. Figure out the different, that's the velocity. Find the velocity of the particle at t equal to 2 and t equal to 4. So what do? Just plug it in and find the velocity. V of 2 is gonna be 12, negative 12 is 3. That will be negative 3. Just plug it in, work it out, and then the other one would be negative 3 meters per second. You got to write that dimensions of it. And the velocity at 4 would be what? Nine meters per second. So at t equal to 2, is it moving left or moving right? Moving to the left because it has negative velocity, you know? I don't know, just let's write down it's moving left. And then here is moving right, to the right. Find all times t when the particle is at rest. At rest is when the velocity is 0, no? Yes. Okay. So what do? Set it equal to 0. Velocity is 0. Yes. Set equal to 0. We can just divide everything by 3. So then this will be t squared minus 4t plus 3 equal to 0. And then we can just do the factor here. Is that negative 3 and negative 1? Yes? Yes? And t equal to what? 3 and t equal to? So at time equal to 1, time equal to 3, that's when the is at rest. Doesn't that answer the question that we missed before? What was the question? When was it at rest? Remember? The previous question? Was it a similar question or no? The one that it was like, when is it moving left to right or something like that? Right here, look, this one. What was it? Let me go back to it. When is the particle's acceleration? Oh, it's talking about acceleration, not velocity. Okay. Okay. It would be actually what I just said. It would be at the extremes. Find the velocity. Let's go. Final time. Time equal 1 second. Time equal 3 seconds. When is the particle moving in the positive direction? When is it moving to the right? So how can we figure out when is the particle moving to the right? Let's do a number line. See, we got velocity here. And we know that when velocity is greater than 0, it's moving to the right. But we need these critical points. These are called critical points. Time equal to 1 and time equal to 3. That's when velocity is 0. T equal to 1 and t equal to 3. So doesn't this help us out anyways? Didn't we already kind of do this to help us out? At v equal to 2, because 1 and 3, isn't 2 in between 1 and 3? What's the velocity? And what's the velocity at 4? We just need to test this left side, which is 0. If I plug in 0, v of 0, it'll be positive. It'll be positive, no? Yes? Some positive velocity. So when is a particle moving in the positive direction? I guess you could say with a negative infinity to 1 and comma 3 to infinity. I got this wrong. Why? That's what I was thinking to myself. It makes no sense. Negative infinity. What does it say here? Read this. For t, what? Greater than or equal to 0. So it does have a leftmost. Finite. It's not negative infinity. For t greater than or equal to 0. So it has a starting point time. All right, moving on. Next. Seven. Where's everybody at?
Sean's at the camping.
Huh?
Sean's at the camping thing where he gets paid to be on the
Oh yeah?
Yeah.
Where, in front of state or what?
No, I forgot.
Huh?
I forgot where it was.
Was that with Mr. Spencer? A particle moves along the x-axis. The position of the particle in feet can be modeled by this, again, third degree polynomial. For t is greater than or equal to 0, less than or equal to 5. T is measured in minutes. Is the particle speeding up or slowing down at t equal to 3? Explain your answer. Speeding up, slowing down. Is the particle speeding up or slowing down? Don't we just kind of take the derivative, evaluate it, see what the sign is, take the derivative again, find what the acceleration is, if positive or negative, if they match up, then it's speeding up. If they're different, slowing down. Yes? Makes sense, no? So let's go ahead and do x prime of t. And evaluate it there at 3. We just care about the sign of it. 9 plus 4, 13 minus, that's a negative 2, that's a negative speed. And x double prime of t, it would be 2t minus 5. X double prime at 3 would be 1. So it is what? Slowing down. It's slowing down. Let's see. Because the particle is slowing down because v of 3 and a of 3 have opposite signs. Eight. Straight line motion again, straight up and down. If a ball is thrown vertically upward with an initial velocity of 80 feet per second, then its height after t seconds is this. What is the maximum height reached by the ball? When it reaches, when I throw a ball up in the air, what's the velocity at the time it turns around? 0, no? Because going up is positive velocity, going up is positive, when it comes down is negative velocity. So at the highest, the velocity is 0. And that's when it reaches the highest. So we gotta get the derivative, set it equal to 0, to find the time it takes to reach that 0 velocity. S prime of t equals 80, and this is velocity, v of t, no? And velocity, and then that would be minus 32t. And when is the velocity 0? And so t equals what? 32. T equals 80 divided by 32. T equals what? Get a calculator. What is that? Is that 2.5, is it or not? What is it? $2.5, no? So now, what do we do? What is the question? What is the max height? What do we do? Into the position formula, no? S of 2.5. Okay, let's go to B. What is the velocity of the ball when it is 96 feet above the ground on its way up and then on its way down? Let's do on its way up first. How do we do this? When the output S of t is 96, yeah, and then plug it into the derivative formula, no? So the output is 96, and we got to figure out when is it equal to 80t, 80t minus 16t squared. Move everything to the right to make this positive, the t squared positive. So 0 is going to equal to 16t squared minus 80t plus 96. Divide everything by 16. Get a calculator. What's 80 divided by 16? Somebody? Is it? So 0 equals 16 divided by 16 works. So be what? T squared minus what? Is that 5? And then plus 6. And then we can just do the factoring here. It'll be t and t will be what? Minus 6 and plus 5? Plus 1? Plus 1? No, no. Is that negative 2 and negative 3? Is that right? Yes? So it'd be what? T equal to what? 2 and t equal to 3. Hold on here, let's second. Okay, so which one do you think is going to be for going up? T equal to 2 and t equal to 3 when it's coming down, no? So now we can go ahead and find it. On its way up would be this one, on its way down would be this one. So we're going to do V of this formula, V of 2. V of 2 is going to be 80 minus 32 times 2. That's 16 meters per, no, it's not meters, it's feet per second. And then that's on its way up. And V of 3 will be 80 minus 32 times 3, and that better be negative velocity. 96, negative 16. One more, let's do maybe one or two more, and that would be it. All right, let's go to number 9. A particle moves along a straight line for t greater than 0. The position of the particle is given by this third degree polynomial again. Some third degree always, almost. Where s of t is measured in inches and t in seconds. What is the velocity of the particle when the acceleration is 0? Basically, when it comes to Salat, this seems to be like this, that you got levels here. So main levels, you got position, you got velocity, and acceleration. And you got to jump to different levels depending on the question. And so here, what is the velocity of the particle when the acceleration is 0? You're given the position function, s of t. You got to go all the way to the acceleration. Find when is the acceleration equal to 0, at what time, and then come back to the velocity function and find what the velocity is. Yes? Make sense or no? S prime of t S double prime of t. So this is acceleration. And you want to know when is the acceleration equal to 0? Which is going to be what? T equal to. And then you got to go back to the velocity function and find the velocity. So velocity of 2 is equal to 3. What is that? Is that negative 3? Make sure you don't forget the dimensions of it. All right, last one we're doing today. This is it. A particle's position along the x-axis in meters is given by this function for time is greater than or equal to 0, less than or equal to 10, where t is measured in seconds. What is the particle's velocity at t equal to 6? So take the derivative, evaluate it at 6. So this is going to be a chain rule. So the outer function well, you know the inner function is this, what's inside the parentheses. The derivative of that, the derivative of sine is what? Cosine pi by 6t times the derivative of the inside, no? And the derivative of the inside is what? Pi over 6. Then evaluate x prime at 6, 12 cosine pi by 6 times 6 over times pi by 6, 12 cosine pi times pi by 6. What's cosine of pi? Negative 1? Negative 1, so it'll be negative 12 times pi by 6. And it's going to equal to what? Negative 2 pi? Negative 2 pi? Don't forget the dimensions. That's going to be 1 point off on the AP for sure. If you that's enough.